everything you never wanted to know about flow logs. So before we start, I would like to thank our sponsors, especially our gold sponsor, Rapid7. Rapid7 empowers you with industry-leading security solutions and strategic expertise to stay ahead of attackers, ahead of the competition, and ready for what's next. Learn how we can help you secure the future and enter to win a meta quest at bit.ly/cloudsec giveaway. Please welcome Daniel.
And welcome to my talk, Everything You Never Wanted to Know About Flow Logs. So who am I? I'm currently doing threat detection at Snowflake. I'm not really a cloud guy, but have to use it because we use a lot of cloud. Before this, doing a lot of offensive security, enjoying computers, coffee, and cats. And I'm going to talk a little quick because there's a lot I want to talk about. So what I hope you'll get out of this, I hope you'll understand some of the differences in how the big three cloud security providers log network traffic. There's more details in the deck, so once it's published, you can feel free to review some of the hidden slides and comments. I'm going to be talking about some of the gotchas or sort of caveats where I complain about these logs, and talk about some of the security use cases. What I really hope you get from this is informed decisions on if these logs will be useful to your organization, and make decisions on like, should I use them, should I not, what's the cost benefit there? What I hope to get out of this is people telling me I'm wrong. There's a lot of things where I was like, that doesn't make sense. So if you see something and you're like, that's incorrect, come tell me afterwards. I'll buy you a beverage of your choice, but that's what I hope to get out of this. So table of contents. Flow logs aren't the most exciting thing in the world, so there's a little bit of settings we'll be doing. We're going to talk about this in the context of Zootopia. We're going to understand these flow logs a little bit more, some of the challenges in working with them, some security use cases, and then maybe some time for questions. If not, then come find me after. So crime in Zootopia. So we have three major crime fighters who help us out when fighting crime. We have the Fuzzy Bureau of Investigation, or AWS, Central Intelligence Agency, or Azure, and the National Snake Security Agency, or GCP. And all of them are going after this group of hackers called Foxes. So Foxes likes to use the internet to do their communications, and the intelligence providers allow us to listen in on some of these comms. So here we have a basic TCP communication where Fox McCloud is sending some data to Tails. So each of them have various login styles in which they capture this communication, right? It's not a full packet capture, that'd be too much information. So with AWS, we kind of get, a brief snippet of Fox McCloud, talk to a Fox. And AWS will then say, Tails, talk to a Fox as well. GCP kind of gives us both ends of that communication, where it'll say, Tails, talk to Fox McCloud, and Fox McCloud, talk to Tails. And then Azure gives us a little bit less, even more. It'll say Fox 1 started talking to Fox 2, Fox 1 stopped talking to Fox 2, Fox 2 started talking to Fox 1, etc. And we'll dive into some more specific examples of what this actually looks like. But I wanted to sort of put this in your mind early. So what are some of the keys to investigations with flow logs? Well, provenance is a word I heard yesterday, and I'm going to use that in this talk. But being able to know where these logs came from, what compute asset or infrastructure generated the network traffic, is super, super important. Otherwise, you're not going to be able to realize value and understand what is making these network calls in the first place. Volume's also a major issue. I double-checked this morning. I think we have a couple hundred terabytes of flow logs a day across our major cloud providers. That's a lot of data. There's a few faux pas or sort of caveats when using these logs, either information in the docs that I feel is incorrect or hard to understand or parse. So be careful about what assumptions you're making. But if you do all these things correctly, you'll be able to answer some tough security questions and improve your posture. So let's dive into these flow logs a little bit more, starting with the Fuzzy Bureau of Investigation, or AWS. So again, some hidden slides here, but one of the key takeaways I want to have is that the format for these is space-separated values by default, and there's going to be sort of different fields correlated with different versions. So when you're setting up these flow logs, understand what order you're putting these fields in. Otherwise, when you're looking at these logs later, you may be confused about what information you're looking at. V5 also has some really nice features, like if you're talking to an AWS service, or the direction of the flow with respect to the interface. So here's a test that I ran just curling google.com, a lot of text. What I want your takeaways to be is that it was a basic curl command. We got about 30 packets. Our instance was the client, and we were talking to Google. And we have a number of TCP flags in this communication, various packet sizes, etc. So what does that end up looking like? Again, if this slide is hard to read, that's kind of the intent. These logs are not necessarily easy to parse by default, so it's important to know what you're looking at when you set up this login. The default format puts these fields in alphabetical order. I don't recommend doing that with your logs. It may not necessarily make sense. When you set up these flow logs, maybe use something like Terraform to standardize the size and then standardize the format and something that makes sense for you. So let's look at some of these key fields in a little bit more detail. we're going to have the destination and source IP address with respect to both the traffic leaving the interface and coming out. So for this basic curl command, we get two flow logs, the instance talking to the server and the server talking to the instance. Again, notice there's no sort of key here. You have to know what order these things were put in order to get some value from these logs. We have source and destination port, egress or ingress with respect to the interface. So the top one was the client talking to the server, or egress traffic, and then ingress traffic back when the server responded to the client. And then packets, and this is one of the first parts where I complain. AWS said that there was 37 packets total in this communication. Every time I ran this test with TCP dump, the amount of packets I logged was never what Amazon reported. I don't know where this delta is coming from. If you do, let me know. And then TCP flags. If you're familiar with TCP flags, you'll recognize 3 as SYN-FIN and 19 as SYN-ACK-FIN, and then you'll realize that doesn't make sense. So what's going on here? This is from AWS's documentation. For short communications, if it's only a few seconds, they'll OR the TCP flags. So you'll see something like where it's a SYN and a FIN, get OR together for a 3. Same with the corresponding communication the other way, you'll get a 19 or a SYN-ACK-FIN. So if you're looking for initiating communications, you'll have to look for TCP flags of 2 or 3. So I'm also a very good coder, so I wanted to look at internal traffic between these things and look at what kind of misses I would get, what does that traffic look like, et cetera. AWS in my testing, just in my lab, didn't have a lot of misses. In production, there are some misses, and we'll get to that in a bit. This is what a miss will look like. It'll say skip data. It doesn't generate one log of these for every record that was skipped. You could have a billion packets that were skipped, and it'll still just have this one log record. So something to be aware of if you're like, oh, I wonder how many logs were missed. You don't know. You just know that some were missed. Another challenge that I had with AWS flow logs was understanding who the client and server was. So let's look at this very sort of trimmed down example. Who do we think is the server in this? You may jump and say, well, the destination address. In this case, you're correct. 119 was the server, 126 was the client. What about this one? If your first conclusion, like mine was, oh, well, 126 is the server, you would be wrong. This is actually the other end of the communication. As I said, for every communication, you get sort of 2 flow logs. So for client to server internally, 4 flow logs. This is the other end of that. How do you know the difference? The TCP flags. Here we see 3. Here we see 3. This was the communication from the client to server. And then here 19, or the server to client communication. So you really have to look at both the source and the destination address, as well as the TCP flags to understand flow direction here. All right, GCP, or the Snake Security Agency. When setting this up, there's this sort of the UI that you're going to get. I recommend checking the metadata box that tells you information about GKE nodes, VMs, other kind of useful information about the flows, and then the sample rate. We'll get to that one in a bit. Again, sort of basic test, curlingamazon.com. A lot of text here. What I really want you to take away from this slide is similar to AWS, you're going to get 2 flow log records. One for the outbound flow and one for the inbound flow. So on the left, we have where the client is the source talking to the server, and one on the right where the server is responding back to the client. So in this case, the client is saying it's the destination, even though it's still the client. Another kind of caveat to be aware of. Again, I wanted to look at lateral movements, sort of what does traffic look like internally. And again, we're wondering, is this the client or is this the server? If you're as confused as me, you're in the right spot, because as far as I can tell from GCP flow logs, there's really no sort of definitive value like you get with AWS or Azure to understand what direction traffic was going. You just kind of have to maybe assume based on what you know the asset to be or the ports. But in this example where I used 2 high ports, pretty hard to tell. Again, this is sort of another example of that, where the destination IP is the difference, but this is actually from the same connection, just from the 2 different instances on either end of the communication. So again, what about capture rates? What are we looking at? It's bad. I did a similar test where I was looking at 1,000 netcat connections between 2 hosts. It says 323 log entries out of 1,000. That's about 30%. If you look in GCP's documentation, it actually does sampling of about 1 out of every 30 packets. So that's a pretty abysmal rate. When I was doing some tests and I was just doing sort of one-to-one communications, I did maybe 10 of these and I got one log and I thought I was doing something wrong until I saw this buried in the documentation. Then they upscale the rate based on what they think the sampling would be to get sort of other parts of that communication. So this was from the destination end, this was from the source end. It seemed to be pretty consistently around like 30 to 60%, just depending on luck and what they were upscaling. And that's especially frustrating to me because when I set the sample rate to 100, you assume 100 means 100. 100 doesn't mean 100. So, a little snaky of them. What about Azure, the Central Intelligence Agency? So they have a slightly different paradigm, right? They're enabled at the network security group level, or if you're looking at sort of like, kind of firewall or, ACL kind of equivalent, whenever a connection is sent, in Azure, it goes to these NSGs and it makes a decision whether it's going to accept or deny it. When it hits that, that's when that connection is logged. So it's not logged at like the interface or the sort of compute layer, it's logged sort of at another sort of interface layer between these two hosts or connections. You get two versions, so the default and then V2 adds bytes and packets, useful if you're looking at exfiltration. They're also written to what I call hot files. I'm not an Azure guy, I don't know if this is the standard, but every minute this pt1h.json gets, I don't want to even say incremented, it's more like augmented or replaced with a new JSON file. So if you're using a tool like maybe we do at Snowflake, where you're ingesting these files every time there's a new, a delta, you're going to get a lot of duplicate records because it's not something where it's like a new line record. It's adding to a single JSON object. So it looks like a new JSON object because there's a new element in the array. So you'd have to do some really creative parsing to figure out what have I already ingested and what have I not ingested, or you're just going to have a lot of duplicate data. So here's kind of what metadata looks like. One of the reasons I chose the Ant is it kind of feels like this was built by multiple people at once, and there wasn't a lot of crosstalk. So let's start with the system ID at the top. One thing I thought was that this correlated with the asset that made these logs. It's actually the system ID of the NSG record, or the rule that you have in place, or the NSG group, sorry. Scrolling down, we see that there's two arrays, both called flows. That's why I'm wondering, like, who was making decisions here? This was a little confusing to me. But this records is the top level object in the JSON blob. Every minute, if there's new flow logs, a new record will be added to this, containing sort of two arrays of flows, one listing the rule that was hit, and then the flows within that rule itself. You see JSON, you think, oh, these are going to be in JSON, right? CSVs. It's a CSV nested within the JSON object. So, luckily they do provide pretty good documentation on what this means. I don't expect you to read it. There's a URL in the slides to get a link to this. But we have the start time of the connection, source address, destination address, source and dest port. If it was TCP or UDP, if the direction was outbound or inbound with respect to the source, or with respect, sorry, to the asset, if the action was accepted or denied, and then another sort of difference here, right? Azure will log if the connection was beginning, be continuing, as in existing over the sample rate, or the end. If it's the end, you'll start also getting some useful, if it's continuing or the end, you'll get other information such as the packets captured during that interval, or the bytes as well. So here we have 10.0.0.4, talk to a server outbound, and it lasted about 6 milliseconds, and it got more data out to it than it sent out. What about lateral movement? Similar to the other providers, right, we'll get sort of two logs, the beginning and the end. So that's a little bit different from the others where you got inbound and outbound. Now it's beginning and end for both the client and the server. What's nice is that Azure is consistent with source and destination address. So here 10.0.0.5 was the source and 4 was the destination or the client. How you can tell the difference is the direction, sort of right there. We have outbound and inbound. So we know that the top was the client and the bottom was the server. Any misses? Not that I found in testing. I'm still looking through some of our production data to see if I can come up with any conclusions. There's no sort of record of a miss like you get with AWS, and there's no documentation on misses like you get with GCP. So it's an unknown at the moment for me. So let's look at a comparison between these logs and kind of what we've talked about so far. There's differences in aggregation intervals, or sort of how often sampling is done and aggregated together. You get some options with AWS, a lot of options with GCP, and Azure says 5, so you get 5. The entity is an also crucial part of this. Like I mentioned at the beginning, being able to correlate these flow logs to the asset that actually made them is a key part of investigations. AWS will give you the ENI of wherever that log was recorded at. GCP will do their best to give you the VM or the GKE node. Azure gives you the MAC and the IP addresses. I don't know why they give you the MAC. I have looked all over our Azure console, our Azure logs. I've reached out to Microsoft. I can't find anywhere else where you can get the MAC of a NIC. So I don't know why they give it to you. Maybe it's for forensic purposes if you get on the box, but for any sort of automated analysis I was trying to do, the MAC address was useless. So that was fun. Recording delay, or the delay between when the log occurs and when you'll see it in CloudWatch S3, seemed to be pretty consistent between the providers. This was just sort of in my lab, so take this one with a grain of salt. Similarly with the sample rate, in my lab, AWS was 100%. There's some notes in the slide about production data that I have. GCP was 30%, and then Azure was also 100%. TCP flags, you get them with AWS, not with the others. Protocols, AWS says all except DHCP, that there are all some caveats like Microsoft licensing doesn't record. GCP gives you those, and Azure only gives you TCP and UDP. Client versus server, you can figure that with flags. GCP, nope. And then Azure does give you that information. What else thought was interesting was the connection decision. GCP doesn't give you that information. So when I was trying to do some tests with port scanning and looking for denied ports, it just logs the connection. It doesn't say if it was accepted or denied. It's just like, here you go. Azure, yes, but it's at the network security group level, not the host level. So if it was blocked at a host firewall or the port wasn't open, you're not going to get that information. You're just going to get it based on the NSG deciding if it's allowed to send that to that host in the first place. So what are some of the challenges? I'm going to speed through this. I'm a little short on time. Drastic differences between each of these. In the code that I'm just going to be sharing, it'll sort of walk through that a little bit more. Asset correlation, or figuring out what asset is on either end of the communication, can be exceptionally difficult. Unclear documentation for various reasons, and then volume. As I mentioned before, we have about 100 different terabytes plus, over a day of these flow logs. So it's important to understand which logs do I need to enable, and what am I going to be doing sort of detection or proactive analysis on, and what do I keep for later for maybe just incident response and documentation purposes. So when you're looking at setting these up, those are some of the decisions you're going to need to make. Is what are my key assets? What do I maybe just want to log for logging purposes? What do I want to log for continuous analysis purposes? So what are some of the security use cases we have? Well, as I mentioned before, what is a flow log? A flow log is some sort of compute thing making a network call and it making a capture of that. So why do we care about these? Often in a lot of environments, you can't really inspect the compute node as much as maybe you would want. Maybe for performance reasons, your agent's too heavy. Maybe you just have gaps in your logging. I'm sure we all do. Or maybe you just don't trust it. Maybe you're well, we're going to assume that this thing gets pwned and we can't really do anything about it, so we can't trust our host-based telemetry. These allow you to sort of observe those second-order effects in order to understand what is this thing doing within our environment. So what is our game plan? Well, we want to be able to collect entities, collect these assets, correlate them with flow logs, develop our use cases, and do security. For our collection strategy, we're going to be combining both config and audit logs. Configs gives us the snapshot in time, but if you're working in an environment where you have short-lived assets, you're going to want to be able to combine that with your audit logs to get a clear picture of your environment at a state and time. And why do we need that? Well, IP addresses can be reused, and IP addresses, unfortunately, are still a key part of being able to correlate assets from what I found. So you need to be able to know the start and end time of when an asset existed in order to know when that IP address was reserved for that asset to properly correlate it with your flow logs. Fortunately, if you want to take a photo, this is the one I recommend. There's some code here that I think we use to really help us do this kind of analysis and correlate our assets together. So this is a lot of SQL code where we sort of build up these entities, do these correlations, and also some security use cases. So I'll zoom through these next few slides. Unusual communication, so being able to baseline what kind of ports you'd expect your computer instances to talk to. Network scanning, with AWS, we at least get reset packets, connections to malicious IPs, and then beaconing as well. Incident response, you can get stuff like hosts connected to you, exfiltration. You can correlate with your DNS data to get sort of true host names. and then potentially correlate with your host logs as well. Thanks to a lot of the folks in the team who helped do a lot of this research and put this together. Any questions?
Thank you. Do questions in the audience just a second. First thing from Slack, I just wanted to highlight, everyone loves your slide design.
Yeah.
So
credits to the Slides Go folks.
Awesome. So props there, and we'll start with a question in the room.
Thanks, Daniel. It was a great talk. Just curious, given the volume and cost of flow logs, what do you think is the value versus cost, security value versus cost kind of trade-off with this?
Sure. So I think it's maybe I'll skip GCP because I think there's some gaps there. For AWS and Azure, I feel like especially when you're looking at internal traffic and very static hosts, like I know that this server should only ever do these ports and these devices. I think there's a lot of value there because you can sort of ingest, say, okay, this matches are expected, cool, we're on our way. But when you start seeing stuff like, hey, why is Ansible talking on 443? Why is Apache doing SSH? Those are the kind of things where you can get some immediate, like, hey, something's off here. Especially if you're like, maybe our vuln management isn't that great, maybe our agent deployment story isn't that great. This is where they can help fill in those gaps.
So I know you published some SQL tools and example queries for looking at flow logs. The parsing of this stuff, it's very verbose, JSON, awkward. Any recommendations for what people should use for getting things into a very SQLable form?
Bias alert, I work at Snowflake, so we have tools that do that for us.
That was a layup, sorry.
Yeah. There is in the code there, it does talk about parsing those logs, and I try and keep it as tool agnostic as possible. So please take a look. If you don't find it helpful, just reach out to me. I'll do what I can to help.
Second.
Great presentation and great slide deck design. My question is around cost. As you were assessing the 3 different solutions, which one did you see was most cost effective?
So I'll say AWS because we were able to sort of have very fine-tuned controls of like, you can enable it on like an account, a VPC, even down to the specific interface level in terms of granularity. You don't get that with the others. Azure also, we're still sort of solving that like duplication issue. And then GCP, because of the gaps, we're still debating like, now that we know this, like what other options do we have?
And one more question. There's a question about the volume of logs and skips, I guess, presumably in AWS and Azure, where generally you're expecting to see most of the logs. If the data is skipped or marked as skipped, is that something you should consider a concern? Do you kind of treat it as normal? Is there anything you can do to try and reconstruct those logs if they're missed?
As far as reconstruction, I don't know. In terms of like what we're trying to do about it, we're still in that research phase. We're trying to figure out if it's certain volumes of traffic over a period of time. Maybe some of our instances are just more chatty and we kind of would expect that. You can also look at deploying third-party solutions for sort of VPC monitoring. That's what GCP recommends as their stopgap. But we are still sort of debating the cost value there.
All right. Thank you very much. Next talk in 10 minutes.